in this lecture, I'm going to explain you what is the work done if we apply a constant force, right? So constant force means when there is no change in the magnitude and direction, right? This is a constant force. Now, let us say if we apply force on a body, then the body changes its position. This is called displacement, right? We already discussed this thing in our previous lectures. What is displacement? Displacement is basically when we apply a force on a body is changing its position. It's moving. That means it is making a displacement, right? Now, to find out the work done, let us take an example of a toy car. Okay, so this is a toy car here. This is a toy car, and when the kids play with the toy car, basically what they are doing, they are applying a force. It is basically a toy car is basically there is a string on a toy car, and a boy is moving this toy car with a string, like so. It is applying a force in this direction like this. So if we apply the force like this, then it will create a displacement, right? Sorry. Yeah. So if we apply, that means this toy car will create a displacement in this direction. Displacement means this toy car will move in this direction, right? So let us say this is called d vector, right? Suppose it is making an angle theta. Force is making an angle theta with this. Then if we break this in two components, then the horizontal component will be, you all know how to find out that this horizontal component will be f cos theta, and the vertical component will be, here it will be f sine theta, right? Because it is creating an angle theta with the displacement, the force. Now, if I need to calculate the work done, then what will be the work done? Work done is the displacement into the horizontal component, because the car is moving in this direction. So I say f cos theta into displacement, right? Now can I write it f d cos theta, right? Or can I write it, if I remove cos theta, that means it is creating a dot product of displacement and force. So this is basically dot product. So I can say it is a dot product of force and displacement, right? Now, on what factors the work is depending? So basically, as you can see in the formula, work depends on what factors? Force, and another one is displacement. Okay, so I can say work is a scalar quantity. Okay, that means I can say work done is a dot product of force and displacement. Okay, and what is theta? Theta is the angle between force and displacement, right? So from, you can see what is theta. Theta, from the figure you can see, it is the angle between the force and the displacement. So I can say work is a scalar quantity and theta is the angle between the force and displacement. Now what is the SI unit? SI unit of work done. So what is the formula? Force into displacement, right? This is the formula. So what is the unit of force? You all know Newton. What is the unit of displacement? It is meter. So what is the SI unit of work done? It will be Newton meter, or I can say joules. Okay, so if I will speak about the work done of the SI unit of work done, then it is Newton meter or joules. Now there are three cases. If cos theta will be 1 if cos 90 equals to 0, and means theta equals to 90 degree and theta equals to 180 degree, right? So now if we consider the first case, case number 1, okay, if force and displacement are parallel to each other, right? That means, so I can make a figure here. This is basically a body here, and I'm saying force and I'm saying displacement, right? They are parallel to each other. That means what is the angle between them? It is 0 degree. They are not creating any angle. That means what is the work done? We know it is FD cos theta. That means I can say FD cos 0 degree. And what is cos 0 degree? It is 1. So it will be F into D, right? So when theta equals to 0 degree, then work done equals to F into D, right? Now case number 2. If force and displacement are perpendicular to each other, if force and displacement are perpendicular to each other. Perpendicular means, again I am creating a figure here. It is a body, it is an object basically, and I am saying force in this direction and displacement in this direction. That means what is the angle they are creating? It is 90 degree. That means theta equals to 90 degree, right? So I can say it is FD cos theta. That means I can say it is FD cos 90 degree, and we all know what is cos 90. It is 0 degree. So it is cos 90 is 0. So work done is 0. Okay. So when they are perpendicular to each other, there is no work done, right? So it is the minimum work done, right? Now if I say negative work, this is the maximum work. The first case is the maximum work. So when is the maximum work? When theta is equal to 0 degree. Okay, now what is the negative work? When theta is, case 3, negative work when theta is greater than 90 degree, or I can take an example, theta equals to 180 degree. If force and displacement are opposite to each other. Okay. So this is my force here and this is my displacement. Basically, we can take an example of a lift. Okay, we are going up in a lift, but the force, the gravitational force is going downwards. Gravitational force is going downwards if we go in the lift, but the motion, the displacement is upwards, right? So this is basically an example, theta equals to 180 degree. Okay, so what will be the work done? It will be FD cos theta degree. That means it will be FD cos 180 degree. That means cos 180 degree equals to -1. So it will be negative work done. When theta is greater than 90 degree, then it will be negative work done. Okay. So work done by a constant force, only you need to remember the formula. Formula is work done equals to F cos theta into D. So force into displacement. And what is the SI unit? Is the Newton meter or joules. And there are 3 cases: when theta equals to 0 degree, when theta equals to 90 degree, and when theta equals to 180 degree. Okay. So this is basically work done by a constant force.